Great. Thanks, Sammy. Today I'm going to talk a little bit about the hazard and bioactivity functionality in the dashboard. Many people are coming to the dashboard with a chemical or some set of substances in mind that they want to understand in more detail. So continuing on the atrazine example, you might ask what kind of hazard data are available. And when we say hazard data in this tab, we're really talking about traditional methodology, either in models for human health assessments or models that are more relevant ecologically. So you can see here on the hazard tab, this is atrazine. And the first thing that you'll want to check is the data type. So right now, the first landing page you come to is toxicity value. This tends to refer to values that have been established as somehow meaningful to a regulatory toxicology process. You can see in the table below, the type tells you the toxicity value type. So in this case, we're seeing military exposure guideline values that were extracted from the Department of Defense, or DoD. All of these data that you see in this table are coming from the toxicity value database. This is a summary level database of these traditional hazard data. And they come from over 50 different subsources like DoD pictured here, or ECHA, or ToxResDB, or other sources from around the web. You can download this table, as Tony has shown previously for all the tabs. Whenever you see this download button, you can download this table as an Excel file. I want to flip to a different type of data. So maybe you're interested in LD50 values or LC50 values if you're interested in things like fish or macroinvertebrates that are ecologically relevant. So here, this human versus eco becomes really apparent how it could be used. So for human, we're looking at really mammalian models, rat, rabbit, dog, guinea pig, and we're looking at LD50s because they're lethal effect levels. But if I flip the tab to eco, I'll see a combination of LD50 and LC50 depending on if the organism is aquatic. It'll be a lethal concentration instead of a lethal dose. And you can always see the source. So a lot of these data came from our EcoTox database, which you can click this link out to the subsource webpage to see. Point of departure is where a lot of our data sits. We use this term really loosely. Point of departure simply means the inflection point of a dose-response curve in which you start to see effects happen. So that's what a point of departure is, and it's this umbrella term that captures things like no ILs, low ILs, no X, low X. And again, we can look at point of departure in terms of human or eco. These are just signifying that there were dose-response effects or treatment-related effects that were considered adverse in some cases, and they're not necessarily a regulatory value used in a risk assessment. This is more inclusive than that. Skipping ahead, you can look at exposure limits. You can look at miscellaneous hazard information. In this case, atrazine doesn't have anything. We couldn't fit into those data types. And then screening levels usually come from regional partners that are looking to regulate a chemical at some critical threshold. And in this case, we have it for human, and you can see the source here is an EPA regional office. We have 10 regions, and they all operate to set these kinds of thresholds. So that's hazard for a chemical that we knew we were interested in from the get-go. But what if you wanted to enter the dashboard because you wanted to find a chemical maybe that was estrogenic? You're interested in estrogen receptor modeling, and you want to understand, using our data, how to find a chemical of interest. So let's go back to the home page and consider bioactivity. So if you enter through assay genes, you can actually find all of the high throughput screening bioactivity data that we have for estrogen receptor that are mapped to the estrogen receptor target gene. This will populate an assay list, and in the case of estrogen, I've chosen it because we have quite a few assays in this domain that you could scroll through. Each of these assays is detailed in this assay list tab, which you can also get to through list of assays. In this case, we're just showing those that were linked to ESR1, the estrogen receptor gene. And if you want to read the short description, it tells you a little bit more about how the assay works and what it's really doing. You can also pull up details in this modal, which will show you a record for this assay, things like a key positive control, 17-beta-estradiol in this case, the description, how the data are normalized, the analysis direction, and other details like that. You can also find how we've processed these data in the ToxCast pipeline. If you're more of a power user and you understand the pipeline, you want to know the methods we applied when we analyzed this, you can find these here under ToxCast pipeline or TCPL processing, among other things like citations. So for this particular assay, we link out to 2 different references that describe the assay in more detail and results from a set of chemicals that were screened. So maybe I'm interested in finding an estrogenic chemical from this cell proliferation assay, ASEA-ER. So I click that assay, and I get to a new page that's populated with the chemicals that have been screened. I can look at all of them. So I can look at just actives or inactives. Here you can see this inactive tab. If I click that off, we'll see everything. I can also find a particular chemical. I'm going to find a favorite, phenol A. So this phenol A was screened in this assay. And I can go to its profile and understand a little bit more about it and its bioactivity. This is the phenol A's record. I can go to its bioactivity tab and see a summary plot of its activity across all of the assays for which we have.
I'd just like to ask everyone to please mute their lines.
So here we are on the phenol A's ToxCast summary page, and you can see this.
We can hear you talking. If you could please mute your line.
Please mute your line. Yeah, we're trying to record today for later purposes, so please mute your line.
Yeah, mute.
What I know. What is it? I think that we're all good now, so.
Okay, great. Sorry for the delay. We had a problem with line muting. I'm going to continue from this page. So here we are on bisphenol A's ToxCast summary page, and you can see at the top this graphical display that's giving you an idea of the activity of bisphenol A across all of the assays that we have currently in the ToxCast database. The way this graph is showing the data is an interesting summary. So the x-axis is concentration in micromolar, and every dot is an AC50 potency value from a curve fit piece of data. So one assay chemical pair is that dot. And then the y-axis is the scaled top. So it's giving you an idea of efficacy in that assay. And because all of these assays are different, some of them are percent activity, some of them are log 2 fold change, or just fold change. And so the scaled top gives us a way of understanding relative efficacy across all of the assays, and that's what scaled top means. That can often be confusing. For bisphenol A, you can click on any one of these points, and it will tell you what the assay was. So at around 0.1 micromolar, there's some activity in this NovaScreen nuclear receptor assay for the human PPAR alpha. and you can read more about it. You can also look at just certain types of activity for bisphenol A. So if all you're interested in is nuclear receptors, you can actually click off all these other categories, for example, and leave behind nuclear receptor in blue. And you can see we have quite a bit of nuclear receptor tag data for bisphenol A. You can also scroll down and you can see a tabular format for these data where you can decide what columns you want to show. You can download this table, just like all of the tables in the dashboard, to an Excel spreadsheet. You can decide to also show the inactive assays. So bisphenol A was screened in 989 assays. In this version of ToxCast, was active in 211, but you can actually look at all 989. Here you can see more details about the assay. Again, we have this modal that you can click that brings up the same assay summary information for more detail. And you can look at links to adverse outcome pathways. You can click out. This will take you to the AOP wiki. So for that estrogen receptor related assay, it relates to an AOP on estrogen receptor activation, and the user can interrogate that further. We have the hit call in the assay, so active, inactive, or not possible to make a call. The top of the curve, the AC50, the log 10 AC50, the max median response. So this is the maximum of the actual response data, the point, not just the curve. And then the cutoff for a positive. So in this case, the data were percent activity, and you had to obtain at least 26.9% activity in order to be considered a positive. And as you can see, there are multiple tabs you can click through of this data if you want to look at it within the GUI. So we were interested in estrogenic chemical. We might look at the EDSP21 tab. In this tab, it's just a subsection of all of ToxCast, where we're pulling out the assays that are of interest for estrogen receptor, androgen receptor, steroid biosynthesis, and thyroid hormone homeostasis. And so here, if you're just interested in estrogen, maybe we're only interested in that ASEA assay, we can bring it up. We can actually look at the curve fit from the ToxCast pipeline and see that it was pretty active until it probably killed the cells here, and that's why that curve drops down. And interestingly, you can see we've tabulated what we call a cytotoxicity limit. This is also present on the summary page of the dashboard. This is a prediction. This is a lower bound estimate on cytotoxicity for this substance across 88 different cytotoxicity-related assays in different cell types. So it's a very broad prediction. It's a lower bound estimate. It's from many different cell types. It's just for context. It's to give you an idea that across a lot of different cell types and many different assay technologies, we tend to see cytotoxicity perhaps begin around 11 micromolar. And in this case, that context is really informative because you can see the cell-based assay signal. Bisphenol A is very efficacious, and then suddenly it drops back down, and there's a little bit of contextual information here. It probably drops because the cells die. You can also interrogate curves from the entire database in this ToxCast Tox21 tab. So here you can filter all the assays either by actives or by gene name, again, in the search dialog box. And the plots will appear here to the right, where you can look at all of the curves from the ToxCast database. So in this case, we could bring up that same curve if we wanted to, CO Biosciences, and see the ASEA curves for bisphenol A. I think something really important to do while you're here on this tab is to understand the level of confidence you might have in using this substance in our current battery of ToxCast assays, which is constantly growing. Depending on the version of ToxCast that you're looking at, we'll have new assays, new curve fitting. The data are evolving. But in terms of using the data, it's really important to think about whether or not that chemical would be stable in our current process. And we have analytical quality control information up here at the top of this tab, where the sample has been processed either by LC tandem spec, GC tandem spec, or NMR, and determined to have a grade and a description of that grade. So in this case, 2 bisphenol A samples at the Tox 21 site were tested. They passed, and they have purities of greater than 90%, and their molecular weight was confirmed. So I might feel really good about using high-throughput screening bioactivity data from bisphenol A because at least the samples were confirmed in terms of their molecular weight. You can click these links out to the NIH Tox 21 website and get more information about what happened in this quality control. So here you can see this is bisphenol A. It has QC grades at time 0 and time 4 months, or T4. And you can click these reports and download them to your computer. In this case, this will be a LC mass spec report for bisphenol A. Finally, you can also look at PubChem data for bisphenol A. There are a lot of assay results on PubChem from many different sources. Many different groups deposit to PubChem, and this is just a portal for linking out to it. This isn't actually our data. This is a link out to data from others on bisphenol A. And then ToxCast models. This is a really important page if you're interested in endocrine hazard characterization. So here we have some summary of ToxCast and QSAR models that are related to endocrine hazard. So the ToxCast pathway models are actually based on ToxCast high-throughput screening bioactivity data. The ToxCast pathway model for the androgen and estrogen receptors are shown here. These information links link out to the papers that describe these models in case you want more detail on their functionality. We have their scores for agonist and antagonist modes at the receptor. So you can see here for bisphenol A, it's a predicted antagonist for androgen because this score is between 0.1 and 1. And for estrogen, it's a predicted agonist. Again, the range for a positive is 0.1 to 1, with estradiol being 1 and bisphenol A being 0.45. These are relative scores, so they're really helpful when you look at other chemicals and try to understand in context their estrogen or androgen activity. Compara and Serap are also shown in this table. These are in silico QSAR models, again with links out to more documentation on how they work. Compara is a consensus model using information from dozens of groups around the world who all developed androgen receptor QSARs, and then we developed a consensus of those. This is work by Kamel Mansouri, who is now at ILS Nicetum. And for Compara, we report out agonist and antagonist and binding modes. This is a little bit of a distinction from the ToxCast models where we don't report binding, although there are binding assays within those models. Serap is essentially the sister model of Compara. It's the estrogen QSAR model that's consensus from 17 groups from around the world. And again, agonist, antagonist, and binding modes are reported, as well as information from the literature. So there's a literature review component as well as a consensus QSAR modeling component for Serap. And in the future, we hope to add more of the models that we've been publishing for steroidogenesis, for example, to this table. Now I'm going to turn it over to the next presenter,